All right, good evening, my friends. This is Miss Casey from your LeRoy Collins Leon County Main Library. I am here with MagLab tonight for Science Night about light, fitting because of the holiday season coming up. We have Miss Yulia here from the MagLab, Mr. Mike, and Carlos to answer the questions. So I'm going to go ahead and have them take it away, and I will see you guys a little bit later with library picks to read about lights. Miss Yulia?
Thank you, Miss Casey. It is so much fun to be here tonight with you all. We're so excited to have so many of you here tonight again. So today's Science Night is on light, and that is actually a tool that we also use at the MagLab. As Miss Casey said, Carlos and our guest, Mike Ozeroff, and I work at the MagLab, and today we bring you a little bit of MagLab science and a little bit about light right onto your devices. So let's jump right into it. Okay, let's go. So before we get started, we just want to make sure that everybody is on board. So we're going to start our first poll session, and we want to make sure that everybody can see and hear us okay. And did you find the chat box? The chat box is probably on the top or the bottom of your screen. And that's where you can type in to ask questions and also to answer a lot of questions that we have for you guys tonight. We also would like to know how old you are. So usually we meet you at the library. This year everything is a little bit different, but we would like to know how old you are so that we get to know each other a little bit. And we want to know from where you're joining us. So please let us know. We have 35 participants today. A little more than half has already voted. So keep voting because we really want to get to know you guys, and we want to make sure that everybody can hear us okay and that everyone can participate. All right, most of us have voted. I think we can close the poll. And everybody can see and hear us okay. That's awesome. And the chat box, one person hasn't found the chat box yet. So as I said, it's on the top of your screen or at the bottom of the screen. Sometimes you have to go to the little bar and there's 3 little dots. And you have to click on there and the chat box will in there. Carlos, did you want to help us out? You're muted.
I'm muted. I'm so sorry. I almost never do that, but I did it. Chat box is down here somewhere. If you go down and you move the mouse, you'll see something that says chat. You click on that, it'll open up the chat box, and that's where you can talk with me, and I will talk back to you.
Thank you, Carlos. So I hope everyone has found a chat box and can participate. Let's see how old everybody is. Okay, 3, 4, and 5-year-olds, 3, 6, and 7-year-olds, 5, 8, and 9-year-olds. The majority or the biggest group of you guys is 10 to 11 years old, 12 of you. 6 are 12 to 14, and we have a couple of older participants as well. We're happy for everyone that's here. Awesome. And most of you all are from Tallahassee or someone from the Big Bend area, another part of Florida, and also 5 out-of-state participants and 2 outside of the US. That's awesome. We're super excited for you to be here. All right, let's move on. And let's chat a little bit about what light is. Any idea what light is? Where does it come from? Type your ideas in the chat box. Talk to me. Where do we encounter lights in our daily life? What does light have to do with color? Why do researchers care about light? And why is light so fascinating? Any ideas? Who can tell me about light? Who knows what light is? All right, let's see. Okay, one participant says light can reflect off your eyes to the color and make sure that your eyes can see it. That's already quite a bit of information. Light is very fast, some person says. Light comes from the sun. Any other ideas what light is? Light comes from gases. Light is an energy from the sun. Reflection, refraction, and absorption. There's a lot of good science terms out there. All right, light equals the sun. Light is bright and has a lot of power. Light is a type of energy. Okay, lots of good information. I hear about the sun. All right. I have a couple of pictures for you guys here. We're ready. We see light is money. Okay, that's an interesting point of view. All right. Light helps us see. That's very good. So lots of ideas what light is. All right, we already heard a lot of really fancy terms, and I'm going to throw another one out there, which is that light is sometimes called a type of radiation. And we can see visible light with the human eye. Someone said a type of energy. That's also a really good way to look at it. Some people say also it travels in waves. We heard it comes from the sun. But then there's also some that say it's a particle. So that's quite interesting. So we're going to go into all of that a little bit more. So one thing I want to mention here is that when we talk about light, most people usually mean the visible light. But there's also other types, so radio waves, X-rays, and we're going to talk about that a little bit and what that means. And you know, some of these types that are not part of the visible light, the one that we can see with our eyes, actually we can only see with special measurement tools. And we'll also talk about that today. Okay, talking about visible light and also tools, I want to show you something and I want to ask if anybody knows what this is. I hope you guys can see it properly. It's a little hard to see with the camera, but who knows what that is? All right, a prism, a color prism, very good. And when visible white light passes through this prism, it actually slows down the light and it breaks it down. And some of the light gets spread out into its different components. So we have white light coming into the prism, and we have several different colors coming out on the other side. And I took a little video for you guys, and because it's sometimes a little hard to see, I put an arrow there for you guys to see what's going on. So I'm going to start the video for you guys. So when the light passes through the prism, it slows it and it bends it and it spreads it out into its different components. So you can see that here. And I would be interested to hear from you guys what it is that you actually see here. If you can type that in the chat box, let me know what you see. What is happening when the light is a rainbow? I see that. All right. It's split up in the colors of a rainbow. So talking about rainbows, we usually don't see them inside and using a color prism. So how do you guys think a rainbow forms? Type your ideas in the chat box. If you have any ideas, how does a rainbow actually form? How do we get all these beautiful colors across the sky? From rain and the sun, that's a really good one. Let's work with the rain a little bit more. The sun plus rain is a rainbow. Okay, that's very good. But what does the rain actually do for us? Carlos, talk to me.
A lot of answers coming in talking about bending light, spreading light, breaking up light. Lots of people talking about rain being involved, but the one word I'm looking for, I have not seen yet. It's an R word. And I saw someone say reflecting. It's an R word that sounds like reflecting. Okay, there it is, refraction. I was waiting for that. That's a good science word. So I'll let you go on now.
Yes, so when we see those beautiful rainbows in the sky, as you guys already said, we need the sun and we need rain. I mean, rain is already in the word rainbow. And as Carlos was saying, those raindrops actually work very similar to the prism that I show you and that I showed you in the video. And it actually breaks up the visible light from the sun, or the white light from the sun, into the rainbow, just like the prism. And and that's how we get the rainbow. All right. So yeah, as rain is formed when water droplets in the air bend and split up the sunlight. It's just working like a prism. So here we have a cartoon of this. So let's look at it. The white light comes in, and then tell me what you see happening and what you observe about these different colors in this picture. Any idea what is special about these light waves as they come out on the other side?
Answers are starting to come in, and they are saying, first of all, that the lines are wavy.
Yes,
good observation.
That's a very good point. Yeah.
The light is being split. I do have somebody talking about light refracting.
Very good.
That's all we've got so far.
I like that you guys are saying the light is wavy. That is a very good observation. And I like that you guys saw that it's split up. That's what we talked about for the rainbow. So the white light gets split up into different components. But let's play a little bit more of the idea about the light splitting into colors and looking at the different waves. What is special about these waves, or what is different between the different color waves? Yep, the light is being deconstructed. Yeah, that's a good way to say it. But let's look at the waves. What is different between the purple and, for example, the red wave? You can see the biggest difference. How are they different?
Wavelengths.
Right, I'll help you guys out a little bit. Let's check how far it is from the top of this wave to the top of the next bend of this wave, and let's do the same with the purple. Any idea what is different here? The length is different. That is a good way to say it. So we learn here that different colors have what we call different wavelengths. A wavelength is really just a big word for saying the distance from the top of one wave to the next. So we see that the red light here, the red wave, has a longer wavelength than the purple one. And that is really important when we talk about the different types of radiation, the different types of light, because really the big difference between them is the wavelength. So we've been so far talking about visible light, and we learned that we can split the white light up into all kinds of different colors, but there's also different types of this radiation. You've probably, and we talked about this last month when we talked about viruses and looking at the lungs, and inside of our bodies, we talked about X-rays to take pictures. And you have probably maybe had a sunburn and might have heard about the ultraviolet sun rays. And you may also have listened to a radio, and that's also all different facets of the same beast, so to say. All right, it's time for you guys to answer some questions. We start our next polling session, and we want to know from you guys, what is light? And can you see all types of electromagnetic radiation? Another question is, different colors of visible light have different, you tell me what, and what can break up visible light? I see lots of answers coming in. Meanwhile, we have 47 participants for our science night. We're so excited that you're all here. All right, I see lots of answers coming in. Almost half of you have answered yeah. All right, what is light? I am curious to see what you guys have to say.
I just wanted to jump in real fast and say that, let's see, is it question number 2? Yes, can you see all types of electromagnetic radiation? And I see a lot of us are filling out that answer now. Humans, we are very boring when it comes to electromagnetic radiation and even magnetism and sensing a lot of these other things that animals can do and we can't. So when I come back as another in my next life, I'm going to be an animal that can see in the ER range. That's what I want to do.
That is a really cool point, Carlos. That is a really good point, because poll question 2, can you see all types of electromagnetic radiation? A lot of you said no, and for humans that is true. And as Carlos said, there's other animals that can actually see more than we can, and see other things that we can. And also, humans are quite clever, and scientists over the years have developed lots of different tools. And in that way, maybe what we cannot see directly with our eyes, we can actually see with tools. So this one was a little bit of a trick question. So another question, what is light? Yes, everybody got that right. A form of electromagnetic radiation. Well done, everybody. And then different colors of visible light have different energy, wavelength, all of the above. Yeah, that's right. Good job there. And what can break up visible light? Most of everybody got it right. That's a prism. Awesome. Well done, everybody. So let's move on and see, how do we see color? I'm curious, and please type in the chat box, why do you guys think that this leaf actually looks green? We learned about white light and it being composed of so many different colors. Why do you guys think this leaf shows up as green? Curious to see what you have to say. Wow, I see one answer that's really interesting. Color bounces off of it. Yeah.
Just to remind everyone, please type in all of your questions into the chat box. I see some people raising their hands, and that's awesome. If you type it into the box, I will ask. And we have a question now. Oh, Yulia, I hope you're ready with your physics, because they want to know, why is violet the shortest wavelength and why is red the longest wavelength?
I guess that's a very fundamental question, why it is in that way. So let me just go back and say that, red is just the one that ends up more on this part of the spectrum, and blue a little bit more on that. And I just want to say that that is, I guess, a very fundamental property of nature, if you will.
Yeah.
So,
and in a way, the question is kind of backwards. It is red because it has the longest wavelength, and it is violet because it has the shortest wavelength. So it's not a matter of the way the question was asked, but you reverse it, and the length of the wavelength is what determines the color that you see. So that's more or less, I think that answers it a little bit better.
And then we also have some answers in here that say about the leaf, that say we absorb a certain color. It also says the leaf could be green because of the sun's energy. Yeah, it has something to do with the light that comes of it. Also, it says because of the color in it. And because light makes things grow, that is true, and it's not necessarily, that's a little bit related to the color.
And Yulia, I got another wavelength question, and they said, with the wavelength, is it the shorter the length, the darker the color?
I don't think that is the case. No.
Right, I don't think they're connected either. I just wanted to make sure, so I'm glad you agree with me.
That is not the case. All right, back to the green light. So we've had a lot of good feedback in terms of absorbing a certain color. We've had feedback on that it has to do with the color of the leaf. So let me help you out here. So if we have white light coming, impinging on this leaf, it actually is the green light that jumps out back at our eyes. So if we look at an object, we actually see the color, or it actually perceive it as to be the color that of light that bounces off of it. So all colors here are absorbed except for the green light. That is pretty mind-blowing. So I have a question for you guys to see if you guys followed along with that. So if you see a red object, what color of light is not absorbed but actually reflected by the object? Let's see. Let's see. So the options we gave you were white light, red light, green light, blue light. And already some of you voted. We have 50 participants by now. Okay. Almost a little more than half of you all voted. So let's give you all a chance to think about it. When you see a red object, so you have white light with all the colors in it coming on the object, and what is it that comes to your eye and what is absorbed by the leaf? Think about that. All right, let's close the poll, Carlos, and most of you all decided red, and that is correct. That is the right answer. All right, moving on. Now it's getting tricky. All right, an object that's white. Why do white objects look white? And this image already gives you, this cartoon gives you a pretty good idea what's going on there. I would still like to know how you guys feel about that. So why do white objects look white? What do you guys think? From all that we talked about and the white light containing all its colors coming up onto it, why do you think the object looks white? It bounces off different. All the colors bounce off. That's a good one. That's a
Julie, I'm going to interrupt you. I've got a question. I don't know if we have a biologist in here, but they want to know, how come dogs can't see color?
I don't actually know that. I am not sure. I can only imagine that it has something to do with the way their eye is constructed. I know that, we have cones and rods. Some of them, one of them being responsible for color vision and the other one for contrast. And I can only imagine that as dogs evolved over time, their eyes possibly changed and that color wasn't as important to them. But I cannot tell you that for sure.
I'm going to do some digging and see if I can find an answer for someone.
That sounds good. All right. White says every color bounces off. I want to congratulate all of you that say that the colors bounce off. Yes, white objects reflect almost all of the visible light shining on them. Good job, everybody. Now let's turn this around. Black objects. Why do black objects look black? Let's have a look at that. Tell me, what are your ideas on that? Their cartoon is really helping you out. And I see in the chat that all the colors are absorbed. All right. It absorbs, yes, because all the colors get absorbed. You all got that. Awesome. Great job. Black objects absorb most of the visible light shining on them. Okay, now we move on to why the sky is blue. And this is a question that came up during our last science night. And we said we were going to talk about that. So now I'm curious to hear why you guys think the sky is blue. Why do you guys think? Why is that? Because we hear about the ocean. Okay, reflections from the ocean. Some scattering. Blue sky bounces off. All right, I have a cartoon for you guys. Let's look at this. So this is a cartoon of our planet with our atmosphere around it, and we have sunlight shining on it. We already heard that the light from the sun is really important to us. So as the light from the sun comes onto our planet, the light from the sun passes through what we call the atmosphere. And the atmosphere is really, really important for us because it contains lots of gas that we like to breathe. And it makes it a livable space for us. So as the light passes through our Earth's atmosphere, the layers of these gases scatter the light. And I saw in the chat that some of you said that. So congrats on that. Job well done. And it turns out that the blue light is actually scattered more than other colors. And that helps the sky being blue. So let's look at it a little bit more with this cartoon. So we have the white light, which is here shown as the different colors of the rainbow. As it hits our atmosphere, it separates into different colors, similar to the prism. And the blue light scatters the most, and it makes our sky appear blue. And and the rest of the light reaches our eyes as white light. Now you say, but wait a minute, at sunset, I see a lot of different colors. So type your ideas in the chat box and tell me what's going on at sunset. I see the same question in the chat. Yeah, it was a good question, but I want to see what your ideas are about that.
Yulia, I have an answer for you. The question was asked of us, how come dogs see in black and white? And I'm going to correct some science and let you know that dogs do not see in black and white. That is a very popular misconception. You are right about the rods and the cones and how evolution has changed them over time. They do not have the same rods and cones that we have, but the rods and cones that dogs have allow them to see yellow, blue, and mixtures of those colors. So that is how they see the world. They do not see red or orange. They see yellows and blues and greens more than anything else, but it is not black and white. So if anybody has dogs and you're shopping for dog toys, those are the colors you're looking for.
Thank you, Carlos. All right, let's check out what you guys said about the sunset in our chat. Let's see what we have. You're only seeing part of the sun on the sunlight. The moon comes out. Light does not reflect as much. The sun is going down the atmosphere, does not make the light blue. There's a lot of good information in that one. All right, let's take a cartoon again. Scientists like to make sketches and cartoons to try and understand and explain what's happening. So at sunset, the light from the sun passes through our atmosphere as well. Again, that's that layer of gases around the Earth that makes our planet livable for us. However, there's a longer way to travel. So some of that blue light that made the sky blue before gets absorbed in the atmosphere, and more of the yellow and the orange can actually come through. And that makes for those beautiful sunsets that we sometimes get to see. All right, that brings us to the end of this session and our pause session number 4. Let's see what you guys think. Who remembers why white objects look white? And what is the layer surrounding the Earth called that the sunlight passes through before it hits our planet? And the sky looks blue because... Okay, 10 of 50 have already voted. We have 51 participants now. We're super excited you all are here tonight. Okay, lots of answers coming in.
I have a question that is outside of what we're talking about right now, but since dogs and cats seem to be popular today, they asked about cats seeing in the dark and what colors cats can see. Cats can't see in the dark, but they can see much better in low light situations than we can. And that's because they have a significant higher number of rods in their eyes. So that's what they're able to see better in the dark than we can see. Ooh, and someone asked about pink. I know a little bit about pink, and pink is weird. It doesn't exist in the rainbow because to make pink, you have to mix red and violet. And if you remember this chart that you saw, those are on the opposite ends of the spectrum, and you can't get them to mix together. So pink doesn't exist in rainbows.
All right, let's close the poll and look what you all said. White objects look white because all colors are reflected. Yes, most of you got that one right. And in what layers surrounding the Earth does sunlight pass through before hitting the planet? That's the atmosphere. That's right. We're happy and thankful for that. And the sky looks blue because blue light is scattered most in the atmosphere. Awesome. Thank you all. And this brings us to a very exciting second part of our night today. We brought in a guest, Dr. Mike from the MagLab. And Mike uses light every day in his research as a tool. And he'll tell us a little bit about light. And we're excited to have you ask him lots of questions. Mike, hey, we're happy to have you.
Hi, so you can hear me, you can see me, right?
We can.
Okay, so very nice talk about the light. So basically you told everything what all the basics about the light, and now the question is why we need the light in MagLab, in our laboratory. So basically the light is a tool, and we are allow the light to interact with the matter, with some materials like water, solids, gases. And after the light is interacting with these materials, it's catch up some important information about these materials. And this, how the light can interact with material, it can come through the material, it can reflect, or can scatter. So there are three kinds of types of light interaction with materials. And we basically detecting this light and can say about the properties of the material. Just simple example, we can say, is it a material insulator or is it metal? How good this metal? Another example, we can say what is the chemical content of the materials, what chemical atoms these materials have. And it's and even sometimes can identify, not sometimes, there is a type of the spectroscopy or type of the optical experiment which allows exactly to say the chemical formula of these materials. And actually, if these tools, so the question is, how do we control the light? And we are using basically two tools which everybody of you knows. First one is mirror, which allows us to reflect and redirect the light. And second one, maybe you can say, I don't see if you, I cannot see myself. So basically, if there is any opportunity to show myself on the screen. So you can see that this is a basic tool, which is flashlight, right? There is a battery, there is a bubble, and in any flashlight, there is another optical component which allow us control how the light propagates in the space. And this is a lens. So the same lens or similar lens which people having in goggles. And this lens allow us to either spread the light in the space or instead or opposite, focus light. And basically some simple experiment. I'm just placing the yeah, so you see I'm just putting the lens in front of my camera, and you can see myself, let's say, larger, a bit larger than the without lens. This is how the lens works. So it can also magnify this object. And another tool here, there is a light source, which is a photodiode, and it's just illuminate a lot of lights. And if I just put this lens back to the flashlight and just turn it on, right, and changing the position, I'm just changing the position between lens and the light source. I can see I can control my beam, and it can be either collimated or spread it. And like
Mike, I want that flashlight. That is a super cool flashlight. I want one. But while I'm interrupting, somebody wanted to know where you are from, Mike.
I'm from Ukraine.
Excellent. And of course, people want to know about cats and what cats can see. So I had to look it up, and FYI, cats cannot or do not see in black and white either. They see in some color, again, blues and grays and possibly yellows. That's what I found out. So back to you, Mike.
And another tool what we are using, this is a laser. Laser is also kind of a flashlight. And if I turn it on, it has also the lens. I don't see if there is a small lens, which was very precise. And the feature of the laser, there are two, that is the light is very collimated. So it's just like a spot, which we can control. It's just like a light, a light beam. So it's just straight line which does not, which propagates, let's say, even along a mile along a long distance without spreading, without getting big. And the origin of this, or reason for this, is just because the light source here inside of this laser is just very, very tiny, shiny spot. The size of this light source is so small, it's much, much smaller than, let's say, 100 times smaller than the thickness of the eye here. Here. And that's why this light with the appropriate length can propagate a long distance. And of course, the laser is very intensive source. And laser, what is the difference between laser and another flashlight? That the laser gives you very precise color. So if the white light is just mixture of different colors, the laser is a pure color. So it's their frequency, it's the light coming from the laser is come at some certain frequency which very defined. And so this is kind of a pure color. And it's so intensive that we need some special tool like a goggle to protect our eyes. But the goggle can be different. And here I have goggle which is kind of greenish and goggle which is reddish. And the interesting question, which one I should wear, take it on my eyes in order to protect myself from the red laser light. So I don't know if this is the question, if somebody has the ideas. Carlos.
So Mike is asking which of the goggles that he just showed you should he be wearing to block the laser light? Should you be wearing the orange-red ones or the greenish-bluish ones? Think about what we talked about earlier with the colors and them getting absorbed. Any ideas?
I just want to point out that one of the cells, I believe it is cell number 3, where we have the lasers, there's a chart outside with lights on it that tells you which laser is being used, so you know which proper eyewear to wear. So if you are wearing the wrong one, we will kick you out because that's not safe. You have to be wearing the right color for the right laser that's being used. Also, Mike, I've got a question for you. Since you mentioned that the lasers are super concentrated and one color, does that mean that we cannot have a white laser?
Yes, we cannot have the white laser indeed. So the white laser is very strong flashlight indeed. So the property of the laser that is just only one single frequency of the laser.
Looking at the answers that are coming in, I'd say a majority of them are saying red for the red laser, and somebody even typed in green laser, use the green glasses.
Let's have a look. So basically you can see the spot behind me, right? So this spot is basically comes, and if the wall is my eye and I'm taking the red light, so you see maybe like this, right? So you can see the laser spot on the goggle, and then that we can see that some part of the light still comes through this goggles. So basically it means this red goggles is inappropriate and totally wrong for getting the safety against the red laser. And if I take, let's say, the green goggles, you can see the spot on the laser, just reflection spot, but nothing comes through this goggles. So basically the green goggles are the good one in order to protect from the red light. Basically green goggles, it means that only the green light can come through these goggles, and not the red light. Not the red light.
The opposite. What if we have a green laser?
And this is this color. for green laser, this is the appropriate goggles.
Thanks, Mike.
Yes. So, yeah. So this is what I wanted to show. And if you have the questions, I am happy to answer.
I just wanted to say, Mike, that there were lots of comments in their chat, and one of them was that they are so excited to meet a person from outside the US because you're the first person from outside the US they have met.
Really? No, magnetic laboratory is one of the laboratories with highest number of international scientists. It's one of the largest laboratories with this high number of work. I work in German National Magnetic Field Laboratory in Netherlands, and here there are a lot. It is very big and international team.
And it's very important for us because, you know, we want ideas from as many different people as possible. People have worked in different places. Everybody brings their knowledge with them, and science is a big discipline to exchange ideas, share ideas, and together we move forward. So it's really important.
But I also want to add in that, Yulia, where are you from?
I am originally from Germany.
And I am originally from Nicaragua. So all three of us are from outside the United States. And so now that person has met three people from outside the US at the very least. We'll have to ask Casey when she comes back. That's right.
All right, there's again a question where Mike is from. I guess not everybody caught that. Could you repeat that, Mike? Where are you from?
I came from Ukraine. This is a country between Russian and Poland. Say it's geographically it's in Europe. Yeah.
Okay.
Mike, do us a favor and can you tell us where you're from Ukraine? Where did you go to school?
It was a public school in the province, so it's not in the big cities. And then later, I just continued my education in the university, which is located at capital. So basically, in our country, best universities are usually located in capitals,
Okay,
or in the big cities.
I got a tough physics question for you guys. I want to know if or how does light bend space-time, if it bends space-time?
It can be, so basically the space and time is something has to do to the relativistic equation. So it's at some point the theory says that the light speed, this is the highest speed which can be anybody can propagate or any process can goes. So this is the limit of the speed. And when the light becomes very intense and very the intensity is very high, the property of matter changes. So in this special certain circumstances, the physics laws is working in the different regimes. And then in such circumstance, one can say that can make a model where the light, the time or space is kind of changing.
There's one really important question as well in the chat, which is, how can Mike point a laser at his hand? Isn't that dangerous?
There are different types of lasers. So this is laser. It's very small and the intensity is not so high. So it means that I can point it on my hand and nothing happens, basically. So this is just like a flashlight. So this is a special type of laser which helps to direct and define the optical axis in some instruments, or also in the usual instruments like in Home Depot. If you buy some tools with a laser, there are such type of laser built in. So they allow to show the direction of the light. And if I'm just placing the lens in front of light, and you can see that the light becomes the spreading, so light can control. But there are some different type of laser which are so intense that can burn even metal. Okay, and first
you work with those in the lab, right?
Such lasers I didn't. My colleagues are working. I am not working. I'm working with the fine infrared. I'm working with something which nobody can see it. It's fine infrared radiation. But for work with such lasers, one need to really work with such goggles, because even the light, scattered light, it's so intense that can burn our eye, and this becomes very, very dangerous. And such a laser, the high intensive laser, they are using in industry, for example, for precise cutting of metals. So the laser can be really big, huge, and dangerous.
Mike, I do have an important question. Someone wants to know why you wanted to be a physicist and why you wanted to work with lasers.
No, physics is just, it was interesting for me to play with lenses, first of all. So we have like telescope lenses. Indeed, I should admit that I was taking the lens, taking the sun, and burn the ants on my backyard, let's say, with this.
Don't do that, boys and girls.
Maybe this is why I become the optical, because one can see the strength of the of the
you
light.
got curious playing with stuff. I did very much the same thing. The reason I am in science is because I played with all the science things when I was a kid.
And I love both of y'all's answers, because they both have the word play in it, which I think is a big deal about people going into science. A lot of people choose to go into science because they can keep playing, because they can keep researching, and just be curious, like we are as we are kids. We're curious to learn all kind of different things, and as scientists, we just keep playing and keep being curious. Okay, if there are no more questions for Mike, then we thank Mike very much for joining us tonight. And
thank you.
Thank you, Mike. If there are more questions later on, save them for the end. And we will move on and get ready for some hands-on science. All right. Today, I told you we need a CD and we need a flashlight. And we're going to do an experiment. And I'm going to show how to do it. And I took a little video for you guys. So take a look, and then you can try this out at home. So what you see here is a white surface, and I come in with the CD, and I turn on the flashlight, and I have my helper turn off the light so that I can better see what's going on in my home lab. And as you can see, we can use the CD or the DVD similar to a Prism, and we can split up the white light from the flashlight into its components. So in your living rooms, kitchens, or wherever you are, you can split up white light into its different color components. So I encourage you all to try that out. I also encourage you to try different light sources. So we talked about this a little bit at the beginning when some kids said, hey, we don't have a flashlight at home. Try to see if you can split the light from your nightstand, night table lamp. Try and see if you can split it up from the kitchen lamp. Try and see how the flash of a cell phone works. So I encourage you all to try this out and send us pictures of it. And the first 5 of you that send us pictures of your experiments and your rainbows can win a cool pair of glasses, and I call them Prism glasses, which break up the white light and you see all the colors that are contained in it, and that is super duper fun to do in the Christmas time.
I'm sure, Yulia, you know this, but the official name of the glasses are diffraction gratings.
That is right.
But yes, I call them rainbow glasses and prism glasses for short too.
All right. Okay, that brings us to the library picks from Miss Casey.
Let me turn my light back on because I was just trying to do the experiment. So I had my cell phone and I had The Lion King. So, and it did not mess up my DVD. So there you go. All right, so you guys were talking. I'm Miss Casey from the LeRoy Collins Leon County Library System again. Hi guys, I hope you had so much fun tonight with the MagLab. You guys were talking about playing and learning and playing while you learn, and that's a part of my job as a librarian too. I get to do fun things with the MagLab and learn and play and do a little bit of research before our big programs each month. So I have this fun Light Waves by David Adler. This will tell you a little bit more about prisms and light waves, and it also goes through a couple of different experiments with you as well. So it's a really, really, really fun book. They were talking about microwaves and gamma rays and X-rays, so all of those are in there, so you can check that out or place it on hold at your library. And then we have a fun classic here. This is The Magic School Bus Makes a Rainbow. So that in this book, you can check out a little bit more about light and color. So that talks about that too. So that's all I have for you guys for tonight.
Okay, sounds good, Miss Casey. I just wanted to show everybody where to find Miss Casey's library pick. So if you go to our website, you can easily find it if you Google MagLab Science Night. You will come to this website, and if you go to the event, there is go to webinar, and there is also the book list, and that brings you to Miss Casey's book list, and she even explains to you how to get a library pass if you don't have one yet. So thank you, Miss Casey, for the book picks. And that brings us to the end of our night. I am very, very excited that you're here, and we hope to see you again in January.
Before we go, a lot of people wanted to know what was the email address to send the picture to.
That is,
there it is.
That is right here, sciencenight@magnet.fsu.edu. We love to hear from you, and we hope to see you next month. We meet on January 28th. You can find the link on our website, and we will learn about temperature and cryogenics. So
if you want to read up on it before Science Night, you can always stop by the library.
There you go. So we are super excited to see you next month. It was great to have you all here tonight. And this is a good moment for last minute questions. And Mike, come on, put your camera on, wave everybody goodbye, or answer some last minute questions.
Yes, please.
I see lots of good comments in the chat. They love the rainbow experiment. They say bye. They say we love this. It was informative.
And Mike, you got a string of goodbyes and thank yous when you left too. I don't know if you saw them, but they were so appreciative for sharing your knowledge with us. So thank you.
Thank you. Thank you for having me.
All right, guys. Then we wish you all a great holiday season. And we're happy to see you all again in January. And I pass it to Carlos for the closing remarks.
I just want to thank everybody for tuning in again. We will see you in January. And before I say goodbye for today, just a reminder to everybody, I always like to say, stay nerdy, stay geeky, stay true to who you are. I have my toys here with me because that is just who I am, and that's never going to change. Stay true to who you are, be nice to others, and remember, science is for everyone. This is brought to you by the National Science Foundation in the state of Florida, which means that all of you are stakeholders in our science, and we thank you for supporting science at the MagLab. Bye, everyone.
Thank you. Bye-bye.